Hello everyone, right? It's Hegde Nikhil Suresh here, and this is my GitHub account with the name It's Me Unique 21. So let's coming to the module 2 repository. That is the project title, and the repository name is AVR based Homespace Automation with daylight monitoring. So let's see what's inside, right? So this is the folder structure, right? Just arranged as prescribed. And basically, if you want to talk about what exactly this project is all about, it is to develop an energy efficient system which will automate the turning on or off of lights, or in case any appliances that we'll see in future. We are thinking that as in future aspects in a these are all done in a home space, the space that you define. It can be your study table, it can be your living room, or it can be a study room, anything. By detecting the human presence and the daylight monitoring, that is added as a responsible feature in the system. Now, how this detection is done, it is with the help of an ultrasonic sensor, and the daylight monitoring that is done using a LDR sensor. And the microcontroller that we have used for this project is nothing but AVR based Atmega 328P. So let's not delay, let's jump into the simulation part of it, and see the working. So here we are in the simulation side. So this is nothing but ultrasonic sensor in front of you, and this is an LDR sensor over here, and this is how the voltage divider that has been done for its interfacing. And see, if you are wondering what this is all about, this is not part of an actual circuitry. So this is actually a test pin, because this is a simulation, we can't get the distance, so 10 centimeter or 20 centimeter. If anyone had ultrasonic sensor, they would definitely get this, what I'm saying. So we have used this, this as a distance. So this is it, if it's very near. As we go on increasing it, this is the potentiometer type, so distance goes on increasing. So far away distance, for say this is 1 centimeters, it could be some 200 400 centimeters, 275 or 230 some centimeters. This is so that is the case how we are doing it. And this is about the lux, that is minimum, it is 1 lux it can take. This is very dark, and if I go on increasing, that means the daylight intensity is high till 999 lux. This is the 1000 lux. So so basically, if I say here this have a relay as an actuator. So this was orbital sensor, relay is an actuator, and we have a bulb over here as an LED. So when this both conditions that we have specified, say for this the condition is if it should be less than 150 centimeter, that the range or the home space area that we have defined is 150 centimeter for it. And here the lux, that is the light intensity here, that is 150, the minimum it should be 150. That is minimum, the daylight intensity should be 150. If it is more than that, that's great, not a problem, unless it is very large. The sun's rays is just hitting you, till that you will understand, you'll close the doors, So here 150 lux is the minimum daylight intensity. Below that, we have a trouble, so that is a dark room, so we have to turn on the lights. So that, don't worry, this project will do for you. So yes, let's jump into it, not much talk. So let's turn on all the power sources, turning on, So when I start here, let's power the circuit. So you can see here the initial condition, as the relay is on, it's tripped, it's not energized. Why? Because this is within, this is within 150 centimeter here. You see that what is exactly 150 centimeter here, it resembles, but the lux, that is enough daylight, then there's 999 lux, so it's enough daylight. So if I try to reduce, let's say the sun is setting, it become dark, man. Oh, now the light turns on, so we have got the light turning on. But what if, if I go away from this place, if I go away from the home space, would the light still be on? Let's see. No, man, it's turned off. So the light has turned off. So that means if I am within the range, that is within 150 centimeter here, and if I am within, if the daylight is less than 150 lux, then only this it will turn on. Either way, if anything is missing, if the daylight, if you're not in the range, definitely, then why that light should be turned on? Let's save some energy, so that's the energy conservation part of it. That's the daylight monitoring, how it is about, in the range I'm talking about. And if it is, there is enough daylight, so why do you need to switch on the lights? So that's better, sitting in the natural light than something artificial source. So this is how the basic working all about. So we'll go back to the repository. Here the next, right, we'll see, right, how exactly a little more about the project, what are the requirements we thought of, right, this project's addresses, right. So these are some high level and low level requirements. So talking about the high level requirements, it ensures, right, it does a proper detection of person or a group of people in a predefined, whatever the home space we have defined here, say it is 150 centimeter, it can be anything different, it can be easily changed, right, with just changing one number in the code, that's all. Next is this project, it facilitates a daylight monitoring. Okay, it monitors, right, at the daylight, as we have seen it. If it is less than 150 lux only, it does its job, right, provided also if it is, right, the person is in the detectable range. Okay, so second is that that is what I'm talking about. If this both things are there, right, then on this was one basic requirement, right, this is very important, otherwise the project has no sense. Okay, so then these are three things that we have implemented. So next thing is about the feature that covers most of the home appliances. Now it's not only that you have a lights in your house, you have many things, right, you have fan, you have, right, it can be some ACs, or it can be some your tabletops, right, table LEDs, table lamp, or something like that. It can be many other things, right, in your home. So whatever you can think of. So that is our next theme and the future. So let's see how we have addressed, how we are taken over from the high level requirement to the low level requirement. So for the detection, definitely we went with the ultrasonic sensor, and you have seen it in proof in the simulation. It is working very fine. So that's done over that part. So daylight monitoring, again you have seen it, we have done through the LDR sensor, that is the light dependent resistor, right, the full form of it. So you can Google it out, so you can get a lot of info about it. It's really wonderful, you can make amazing things with it. This is the LDR sensor, and definitely we have seen it, it is working really great. So the next is that, right, if it's an AND condition, AND logic, that we'll see in the flow chart, right, you don't have to worry about now, right. Those two conditions are satisfied, that is daylight is less, right, there's not enough daylight, and the person is within that home space or the detect, that means indirectly within the range of the ultrasonic sensor, then the control signal will be sent by the microcontroller to the relay. It will energize the coil, and that will switch it off. As this we have all seen it, and it will turn the bulb on. So this is how we meet our requirements. So next is about the design. So we'll talk about the block diagram, schematic diagram, and flowchart. So this is the block diagram. So at the heart of it, this is an embedded system. At the heart of it, we have the controller, and the controller is AVR based. As I'm quoting it again, AVR based 8 mega 328p microcontroller. It has a power source, no doubt. You need a power, right? So AVR itself needs power. So definitely it also needs power. So then this is the input side. The LDR sensor we have, an ultrasonic sensor we have. Both are a form of an analog sensor itself. And then at the output end, we have a relay module where the energizing part goes in, right, and it energizes the bulb accordingly. So if I go to the flowchart aspects of it, right, now next go to the flowchart. Let's go with the flow. You're starting it, you are including all the necessary files means for the microcontroller, for the running of the microcontroller, some project configurations that we are doing, all, right. And then we are talking about the peripheral initialization. We have to initialize it. Then we are doing ADC initialization. You have to do some additional initialization. And this is the timer register initialization, because we are using a unique method, right, to capture the echo signal that is being, right, produced by, right, that is being sensed by the ultrasonic sensor. So that is coming into the microcontroller. So that we have to capture it. So we are using an input capture method, the rising and the falling edge. When we are starting at the rising edge, we are creating starting a timer, and falling edge we are turning off the timer, and we are noting down the time. So for that we need this, and enable, you have to enable all the global interrupts. We are using some interrupts, so definitely this is a good step ahead. And while one condition, you have to run it constantly. We'll be reading what is the range, right, from the ultrasonic sensor, flux from the LDR sensor. We'll compare, right, if the range is less than 150, yes, so that is what we set, right. With this prototype example, you can change it. So if it is yes, okay, then only it will proceed further. Otherwise the relay pin will remain low itself. If it is high, then it will become low. Otherwise it will remain low itself. If flux is greater than 642, now you would be astonished. What this person was saying, that if a light, right, that should be less. Yes, change the greater symbol, inequality symbol, and also change the value. It's not like that. See, if the daylight intensity is more, that means the resistance is less. Okay, so it's an inverse relationship. So that's why it's a greater symbol. And 642, okay, don't worry, this nothing has to do with the lux. This is a decimal equivalent, right, because you are feeding the LDR to the ADC. Now the ADC right? What are the analog signal that is corresponding to the 150 lux? Now when it is converted into digital equivalent, so we saw that inside, right, the MCU port register, we saw that actually this is coming somewhere, right, to the 642. That's right, that's the decimal value. So for the programming, definitely we have to use the decimal or hexadecimal or binary. So we can't go with this one, right? So we use 642. If the lux is greater than 642 means if the intensity is less than 150, then only it will turn the relay pin high. And you know that what happens when relay pin high, the bulb will turn on. That's all. There's a schematic diagram how we have interfaced it, how we have created a potential divider with the 1K resistor. 5 volt we are given as the pull-up as the voltage source, and this is ultrasonic sensor. We know that it has a VCC ground, definitely to power it up. We have a trigger pin, we have a echo pin. Okay, it sends a trigger. We have to send it. It will not send. It's like informing you're saying to some person, hey, ultrasonic sensor, do sense what is the distance of that object, right? If there is an object, do sense what's the distance. So you're telling it. So you're passing a pulse, right? Then ultrasonic sensor will generate ultrasonic wave, say 40 kilohertz, right? So you can see it all in the datasheet, and that is included in the requirement part of it, requirement section. In the reference section, this is included. You can check it over there, and then it will generate a echo pulse. So that is, as I mentioned, it will do the input capture method. We can get the time, and using a specific formula, right, that you can go through in my implementation folder, right? So there, all it is well documented, it is well commented, so you will understand it. So then you have, right, when these two conditions, right, it's something like AND logic I described earlier. These two conditions are, then the signal, right, from here the control signal goes, this closes, how it turns on. So about the schematic diagram part of it. Okay, so now we are coming to the most important part, that is the implementation. So here, right, again implementation, we have so many folders, right? Here in the INC we have all the header files you can go through. Here SRC we have all the main source code files, you can definitely go through it. So that is individually to read the ultrasonic sensor, to read the ADC, right? So something individual source code files you have. This is the build. Actually here, this is how, right, this .elf file that we get, right, this is actually we are loading into the simulation, right, there to the firmware. This is something like a firmware, we are loading into it. That's how we get the simulation. So this is very important, so that we have placed in the build file folder. This is for the documentation, all files you need, you can get it, you can exactly see why that function is used and what are the parameters and all, what does it return. You can see it's documented, there's a link inside. So simulation, right, it includes the simulation file, all the simulation documents, right, all the scenarios that I have spread, they are more in deep, right, in more adept. It could be more clear if you look onto it. This is how, right, if you are interested, at least interested, you can, if you are at least interested, you can run this program. You can clone my repository, have that permission. It's a Creative Commons license, and right, you can go to the 3 implementation bar folder, right, that is this folder. You can go inside and you can just, because we have included a make file, so it is very easy. You can have a make all command, so then you can see your program running, this .elf file running, right? You can generate a .hex file if you want to make it in real practical, or you can do in simulation with the .elf file. So this was all about it. This is the main program which integrates everything, and you get it. But then you have source, right, you have source code, again there are internal programs in it, you have header files, right? So that's all about it. And finally coming to the test case aspects of it, that is the testing part of it. That's the end. So overall working system, if you ask me, so this is the test that we have performed, that if an object is within 150 centimeter rate, intensity is less than 150, so expected output definitely was bulb to turn on. It happened, great. This was all requirement based. So again, if it is within 150 but daylight it was more, that was good amount of daylight, why should we turn the light off? So definitely expected, everything happened as expected, it's great. More than 150, daylight is less than 150 lux, so it's still off. Any combination is still off. It looks like a NAND operation, like something like a 0 0, it's 1. So LDR sensor, right, is a unit testing. Unit testing in the sense, I mean that that particular unit as a sensor, you have tested it. So what is the minimum measurement? We are going for the boundary based analysis. That's the minimum measurement of daylight intensity that is possible. It was 0 lux, definitely it measured 0 lux. Maximum it was possible, we expected it should be more, because 10,000 is lux, right? What if you see the external natural sunlight and all. So but you know, it has a limitation, right? It can, as it is, we are using it inside, so not a problem. And 999 lux, still that only it can measure, right? That we have seen in even in the simulation part of it. Measures required daylight intensity. Yes, we needed 150 lux it measures. So test is passed. It was requirement based. So coming to the ultrasonic sensor unit testing, again the minimum measurement of distance possible was 1 like centimeter that we thought, but obviously there are some limitations. The actual output was 4 centimeters. This is again a boundary based analysis. Maximum measurement was possible, right, because it was mentioned in the data sheet, right. Basically it was a 400 centimeter, but when we actually tested it, right, it was something 275 to maximum. It was like this was in a boundary 275 to 280 centimeter. That's all, not more than that. So this is a boundary based condition again. But measures required distance we needed only till 150 centimeters. So yes, it does its job well in this area. So that's all about it. Even the testings were great, had a great insights that you can, even if you want to have a deeper understanding, please go through this repository, right, or you can follow, right, this it's me unique 21 this GitHub account. And if you have any feedback or suggestions regarding this project or anything about it, you can tell, hey Nikhil, you can make some additions, right? This is the thing that could, or you can tweak this, Nikhil, right? This would be great. If you have such feedback or any suggestions you have, so please reach out to me at nikhilsureshhegde21@gmail.com. Till then, thank you.